So when we were together last, we were talking about carboxylic acids. And here's an example problem. We'll do an example problem together. We already know probably what these are straight in our head. So this will take just a few seconds. So let's bear with everybody until we make it through. Methanoic acid. Meth is one carbon. All right, so C double bond O, OH. And the answer is, yeah, that's it, because on this side, there's just a hydrogen to make up that fourth bond. That's all that there is to methanoic acid. Ethanoic acid, C double bond O, OH. There's my first carbon. There's my second carbon. Propanoic acid, 1, 2, 3, and there on the end is my carboxylic acid. Butanoic acid, but, 1, 2, 3, 4, double bond OOH. There is my 4 carbon chain. Pentanoic acid, 1, 2, 3, 4, 5, double bond OOH, pentanoic acid. And then propanoic and trans to butanoic acid is really where we ended that last video. So we already have done those as examples. So go back, take a look at your notes to see how we handled those names. Now, here's the kicker. You feel good about that, don't you? Yeah, this is going to be so easy. This is going to be not a problem. What's he talking about? I got this. Okay, well, now we need to learn how to common name them as well. So, in the world of carboxylic acids, we have some common names. These common names, I'm going to focus on 6 or less as far as the number of carbons go. So we're going to have a common name for 1 and 2 and 3 and 4 and 5 and 6 carbons. Now, they do go higher than that. They do, and I'll show you at least 7 and 8. But for the most part, it seems like what the textbook likes to give us and what we see normally in an entrance exam and that kind of thing would be things that are lower than 6 carbons. But we'll do 7 and 8 just to make sure, right? We go above and beyond in here with me, above and beyond. Toy Story. So let's talk about the first common name. The first carbon name is something with 1 carbon. So we just called that methanoic acid. Okay, well that's great, but there is a common name, and the common name does not use the word meth. The common name uses the word form, and it still uses the ic acid at the end of the name. So this is called formic acid. Formic acid. If you ever get into an ant nest, and that ant nest loves to bite and sting the crap out of your feet, that's formic acid that they are injecting into you to make it burn and sting. They're little walking vats of acid mouth. Number 2, 2 carbons. Well, this also has a common name. This common name is acet. A-C-E-T. And I add the word ic, and I'll add the word acid. So a 2 carbon common name would be acetic acid. That's vinegar. A weakened solution of acetic acid is vinegar. Okay, so we're going to keep this up. 3 carbons. Well, this common name is propion. Propion. Propionic acid. Propionic acid. Number 4. This is bute. But we're going to put a Y in there. Beauty. And we're going to put an R at the end. So now this word turns into butyric. This is butyric acid. The smell of rotten, clabbered milk or cream, any kind of rancid butter, any of those nasty, disgusting smells comes from butyric acid. Students that I don't like, smear their lab drawers in butyric acid. It stays with them for weeks. All right, number 5. 5 carbons in total. Well, we have a common name for this, and we use Valer. V-A-L-E-R. Valer. And this is ic acid for the carboxylic acid piece. So valeric acid. If you're ever in Virginia, especially, where I'm originally from, we have gas stations. Those gas stations are called Valero. That's the first thing that I think of. I know that's kind of nerdy, isn't it? But I look at Valero gas station and I think of valeric as far as the carbonyl family. Number 6, we have a common name for a 6-carbon family, and this is capro. Almost like caper in Italian cooking. Little, tiny, little bits of sour nuggets that are delicious. So this is going to be called caproic acid. And number 7, I told you we're going to go above and beyond. If you're ever given a 7, this is called N-acetic acid. And number 8 is going to be caprylic acid. So these two, not so much. We don't really see those quite often. I'm going to go ahead and give them to you if they're there. But what we will see more than anything will be 6 carbons and less. Form, acetic, propionic, butyric, valeric, and caproic. Those are your 6, folks. And those are the 6 that you're going to have to keep in mind. And I hate to say this, but memorize. Very, very important as far as the common nomenclature system goes. All right, so let's kind of put the pieces together. So if I put these pieces together and I give you structures, let's take a look at some examples. The first one is a 1-carbon chain. IUPAC is going to call 1-carbon chain meth, and we add the "and" for methane, drop the E, add oic acid, methanoic acid. We did this one, ethanoic acid. We did this one, propanoic acid. We did that one, butanoic acid. However, in the common nomenclature system, common name for a 1-carbon chain is form. So methanoic acid is the IUPAC, and formic acid is the common name. Acetic acid, CH3COOH. We learned that probably in General Chemistry 1 and 2. Propionic acid. Okay, 3-carbon chain. CH3, CH2, carbon, double bond OOH. Butanoic acid or butyric acid. There you go. Your choice. IUPAC name or common name. Here's the next one. Pentanoic acid. Makes sense. 5 carbons. And the common name is valeric acid. Next one. Hexanoic acid. There's my 6-carbon chain. And the common name is caproic acid. Now, these two are kind of weird. Just bear with us. This is a carbon that's single bonded to a carbon, double bond to a carbon. We've already did this example. We called this propanoic acid. This is also called acrylic acid. That is a common name that group comes in because it's a very common carboxylic acid that's out there. One of the first that we kind of was working with and naming. Therefore, it gets a common name as well, and we call it acrylic. And then finally, our last one was this that we learned in the benzene family. Look, I'm tying it together again. Look how I'm weaving this picture. Here is a benzene ring, and we can call this IUPAC-wise benzene carboxylic acid. So this is kind of different because it's a ring system. Ring systems we do handle a different way. I haven't really elaborated on those yet. This is our first encounter with that. So IUPAC is going to be the name of the ring, benzene, and then we add carboxylic acid onto the name. That's IUPAC. But the common name is going to say, call this benzoic acid. And that was one of the groups of benzenes that I told you to memorize and to know back in the day. And now it's come full circle yet again, but this time we're not focused on the aromatic. This time we're focused on the carboxylic acid piece. Okay, so I hope this is a little bit more comfortable, but it's something that we're going to have to do some practice with. So let's just get started. So here are two example problems. Up at the top and the one at the bottom, they want me to name them. Notice it doesn't really say how to name them. So because it doesn't say how to name them, by default, I go to IUPAC. That is what they really kind of want me to do. So until I start learning different ways of naming these things, or until it tells me name it using a common name, I'm just going to name it IUPAC and call it a day. So let's start with the top one. So the problem here is finding the longest carbon chain that includes the carboxylic acid piece. All right, so there's always where I'll start. It's going to be right there. So there's 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Which way do we want to go? All right, well, if we go to the left, there's 6, 7. If we go down, there's 6, 7, 8. All right, so 1, 2, 3, 4, 5, 6, 7, 8. We're going to name this with an 8 carbon chain. I'm going to IUPAC it. All right. So octane. And those directions said, you need to get rid of the E. Okay, well, not a problem. Octanoic acid. But that's not all of the structure. I can't forget about the rest of it. Okay, well, what I mean by that is right here at this carbon, we left off this piece. We've got to name that piece. This is carbon 1, 2, 3, 4, and 5. This is carbon number 5. So at carbon number 5, I have a group that's hanging off of the main chain. That group is a 2-carbon group. And just like we did in Orgo 251, we're going to look at that grouping and we're going to say, all right, this is going to be a 5. And that 2-carbon piece is called ethyl. So the IUPAC name for this structure is 5-ethyl octanoic acid. There we go. No common name. And one of the reasons is we haven't really talked formally how to do it as a common name yet. That's a whole different ball game. This has a substituent on it. We talked about common names with no substituents, just straight chain carbons all the way through. Nothing hanging off. And that's a different type of rule that we have to add into the mix. So we'll get there. We're just not there yet. All right, the one at the bottom. Recognize this? This kind of diagram is a wedge and dash. So what you should have remembered from Chemistry 251 is the wedge is pointed towards you and the dash is pointed away from you. And what we hope in these structures is that the lowest atomic number that is immediately attached to that carbon right there, smack dab in the center, there it is. That atom with the lowest atomic number is pointed away. If so, then this is great. It works as expected. If not, it's backward. All right, so what do I mean by that, right? I mean, I'm kind of rusty on stereochemistry, aren't I? Okay, well, let's kind of go through and review. I do this just the same as before. I count the longest carbon chain. All right, so here's my COOH. Remember, I said this is shorthanded for carboxylic acid right there. So there is carbon number 1. Then here is carbon 2. And then that center one is carbon 3. Now, if I go left, that's 4. But if I go up, that is 4, and then next one is 5. There's the longest carbon chain. This is a pentane right here. All right, so pentane, P-E-N-T-A-N-E. I drop the E, and I add oic acid. So pentanoic acid. That is what that represents. There's my longest carbon chain with carboxylic. So on carbon number 3, I do what I always did before. I just forget about solid and dashed wedges at this point. I'm not doing anything with them. So at carbon number 3, this group is a methyl group. There's a 1 carbon piece hanging off. So 3-methyl pentanoic acid. It's the same old IUPAC rules that we've used over and over. Nothing different yet. Except for the modified ending. That's all that we've done. Now, because of the way that they've drawn it, I need to bring in stereochemistry. And stereochemistry gave you an R and an S. Rectus, not rectum, because I know that this material you would probably want to shove up somebody's rectum before it's over. But rectus is right-handed, and the S is sinister. That's left-handed, because left-handed people like me are evil. That is the stereochemistry world that we had back in Chemistry 251. R and S. Right-handed, left-handed. Oh, gosh. Okay, so I need to figure out which way this molecule is oriented. Is it like my left hand or is it like my right hand? This is how we do that if you need that quick review. Not a problem. That's why I'm here. So here's the center carbon. That carbon is a chiral carbon. A chiral carbon means that there's 4 different groups attached to it. If there's 4 different groups attached to that carbon, then it is a chiral carbon, which shows stereochemistry, which means that it shows R or S rotation. All right, so there's my carbon in the center. And up above, I have a carbon. And down below, I have a carbon. And then over to the left, I have a carbon. They all tie. They're all carbons. Notice I didn't do anything to the wedged one. That is lowest priority. Phew, put it in the back. Forget about it. Who cares about hydrogen? So I only rank these 3 groups. All right, so carbon, 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 it's all a tie. You go to the next one. That's how this works. So the next one in line is another carbon. Then the next one in line is another carbon. And then this one, it runs out. There's this hydrogen that's there. So this is probably my lowest group number. I'm just going to mark this with a number 3. Out of the 3 groups, that's the lowest one. I rank it 3rd. Well, these 2 carbons and these 2 carbons are tied. I go to the next one. This carbon up here runs out. No more. This one down here at the bottom goes to an oxygen. Oxygen beats it out. We're looking at higher atomic numbers. That's what we're looking at. So carbon, carbon, carbon have the same atomic number. I go to the next one. Carbon, carbon, that one runs out. That's why this was ranked 3rd. Then I go to the next one. This one runs out. This one goes to an oxygen. Well, oxygen has a higher atomic number than nothing. So this is ranked as number 2, and this is ranked as number 1. So in this system, there's identified group 1. And then I go this way to get to group 2. I go that way to get to group 3. This is counterclockwise. This is going backward. This is going sinister. I hope that you never see a clock go backward, because that happens in scary movies. That's sinister things that are around that's making time go backward. It's always one of those staples in a scary, creepy poltergeist movie. All right, so this is going counterclockwise. Therefore, this is a S rotation or around the chiral carbon. And this is happening at carbon number 3 of the main chain. That's where this chiral carbon is at. So we need to put 3s out in front. So the 3rd carbon of the chain has a S stereochemistry. And then we name it 3-methyl pentanoic acid. If this group number was not the lowest that pointed backward, then we flip it. This goes counterclockwise, but we have to understand, okay, it's flipped. It's really going clockwise. Therefore, that is the R rotation. So S is counterclockwise. around that chiral center, and R is going to be clockwise around that chiral center. That's what we're after there. All right, so if that was kind of rusty, or maybe you've never seen that before. If you've never seen that before, I'm sorry. But that also means that you probably need to go back into your textbook and find the chapter on stereochemistry and do a quick review or teach yourself, because they're assuming sometimes that we know this already, and they're not going to take the time and go through and review it all over again. Okay, so let's do some more of these examples. We'll just keep doing them until we get a little bit more comfortable. So let's draw the structure for trans, 3-methyl cyclopentane carboxylic acid. Okay. Trans 3-methyl cyclopentane carboxylic acid. Yeah, there's everything in the IUPAC name that they assume that you know at this point, that you can put the pieces together. So cyclopentane, that is a ring structure. And we kind of already mentioned this about benzene. We just said we named the whole ring. We don't even modify that ending. We just name the whole ring. We don't drop the E and add oic. So in other words, we don't call this cyclopentanoic carboxylic acid or cyclopentanoic acid. We just call it cyclopentane. So that's where we'll start. So cyclopentane is a ring with 5 carbons. And off of one of these carbons, I don't care which one you pick. You just pick one of them. You're going to draw the carboxylic acid group, which is COOH. That's the shorthanded version of it. Okay, so there's a start. But now we've got to do 3-methyl. Well, if we're going to do this and name it as a carboxylic, then that means that this carbon right there is carbon number 1. Now, I don't really care which way you go around the ring. You'll end up with the same answer. It doesn't matter. So if you want to go counterclockwise because you're sinister like me, then do it. If you want to go clockwise around the ring, then do it. I don't care. So there's carbon 1, there's carbon 2, here's carbon 3. So at carbon 3, I've got something. And that something is a methyl group. Okay, so a methyl group is a CH3 group. There you go. There is 3-methyl cyclopentane carboxylic acid. That's what that means. So we're close, but not yet correct. And the reason is because it gives me the trans that's out in front. So I've got to make sure that in the structure, I tell you, I convey to you that we're using the trans form of the molecule. So trans, again, means opposite sides. So the way that I show this is that I pick one of the bonds. I don't care which one you do. Just do one of them. It doesn't matter. Not to me. Just pick one of the bonds and shade it in. There you go. There's the solid wedge. And then the other bond, you're going to make a wedge. But you don't color this one in, because that would mean it's the same side. This one gets a different notation, and that is a dash. So there is the solid and dashed wedge notation of the trans molecule. Trans 3-methyl cyclopentane carboxylic acid. There's your structure right there, folks. If this was a cis, then you would color those wedges the same. They could either both be solid or they could both be dashes. It doesn't matter. The only thing that means is that they are both pointed towards your face or they are both pointed away from your face. And in this notation, one is pointed towards your face, while the other one, the methyl group, is pointed away from your face. So there you go. There's a start. Let's do another example. We'll do 1, 2, 4, benzene tricarboxylic acid. Oh, not really done anything like this either. It doesn't matter. IUPAC, use what you know. IUPAC is going to be the same. It's pretty much standard. Now we know what a carboxylic acid group is. So let's kind of dissect the name and see what they want us to do. All right, so benzene, I know what benzene is. I mean, that's another aromatic. That's why they named the whole thing. So there you go. There's a ring structure. And off that ring structure, it looks like on spot 1 and on spot 2 and on spot 4, I've got something. I don't care where you start. You just start somewhere. So most of the time, people tend to start here with carbon number 1, and then here is carbon number 2, and carbon number 3, and then carbon number 4. So at spot 1 and at spot 2 and at spot 4, I've got something. What is that something? Well, tri means 3. There's 3, which is why we have 3 numbers. It's kind of matching. That's what we want to see. There's 3 carboxylic acid groups. Tricarboxylic acid. That's how we handle ones with multiple carboxylic acids. So what that means to me is that there is a COOH there, and there's a COOH here, and there's a COOH there. There is 1, 2, 4 benzene, because that's the main carbon chain, and there's 3 tricarboxylic acid groups. There you go. Keep in mind, folks, that COOH is really a C double bond O OH. All right, so there is an intro to nomenclature for only carboxylic acids, but we're not quite done, because I told you there's something else that comes along that's a little tricky, especially in the common name world, and we need to kind of dabble just a little bit into the common nomenclature system. So that's what we'll do next in the upcoming video.